Hello, students and friends. I'm Manoj Verma from Mumbai in India, and in this video, I'm going to discuss a few multiple choice questions which are based on the acid-base titration curves. And I've taken these questions from the Pearson edexcel A-level exams, but they are useful to all the A-level students and also to the students appearing in their IBDP exam. So let's start with the questions and their solutions. The first question goes like this, that the titration curve shown is produced when a base is added to an acid. And this is the titration curve. And you can see it starts from the pH near about 3, and then it ends at a pH around about 14. And so what are the options? Which indicators could be used for this titration? Use your data booklet. So the students should know that in when we select the indicator, it is based on the pH range, which happens at the end point. So if you look at this titration curve, then the vertical part of the curve indicates the pH change when the endpoint has occurred. So endpoint occurs when about 10 centimeter cube of base has been added, because there is a sudden jump in the pH value. So you have to look at the vertical part of the curve, and you have to see the pH range. So roughly we can say the pH range is from 6 to, let's say, about 10.5, 6 to about 10.5. And then looking at the indicators and their pH ranges, we see this in the data booklet. So as I said, that the pH range that we see is about 6 to 10. So if you look, this is the pH range, 6 to about 10. It corresponds to bromothymol blue, phenol red, and phenolphthalein, which has been dissolved in ethanol. So that is really insignificant. And therefore, these are the three options: bromothymol blue, phenol red, and phenolphthalein. So let's see that where we have that option. So if you see that B is the correct option: bromothymol blue, phenol red, and phenolphthalein. Okay, now which acid and base could produce this curve? Now you have to understand that the starting pH is around about 3, which corresponds to a weak acid, because if the acid would be strong, then the pH would be around about 2 or less than 2. So it indicates a weak acid, and the endpoint is about, after the titration is over, the endpoint, the volume, sorry, the pH touches about 12, which indicates a strong base. So weak acid and strong base, so A is the correct option. Now we go on to some other questions. The structure of malic acid is shown, which could be the titration curve when sodium hydroxide is added to malic acid. So the point to be noted in this is that malic acid is a diprotic acid because it has two carboxylic groups. So it's a diprotic acid, and therefore such a titration has two humps in the titration. So if you look at this one, then there is only one hump, one vertical part, so this is not the correct answer. This has three vertical parts, so this is also not a correct answer. So we look at two vertical parts, so either A or B. But because sodium hydroxide is added, that means the starting pH should be acidic, but here the starting pH is basic, so obviously A is the correct option. Okay, we go to the next question. Which two solutions, both of concentrations 0.1 mole per dm cube, have been used to produce this titration curve? So as you can see that the starting pH is around about 3 or 4, which indicates a weak acid, and this indicates the 14 pH, which indicates a strong base. So it indicates a weak acid and strong base. This corresponds to B, the weak acid, methanoic acid, and the strong base KOH. A solution of sodium hydroxide of concentration 0.008 mole per dm cube has a pH. So it is sodium hydroxide is a strong base. So its pH would definitely be towards the alkaline side, and uh, so above 13 does not look to be possible, because that would be for about the concentration, which is about zero point 0.1 mole per gm cube. So 9 and 11. So we'll have to do a bit of calculation over here. So so what would be the uh, 7 and 9 also is not reasonable. 9 and 11, or 11 and 13. So it requires a bit of calculation. So if we find out the POH first, so if we find out the POH, then the POH will be the negative log of 0.008. So if we approximate it to 0.01, that means the POH would be about 10 raised to minus 2. That is, POH would be about 2. So the pH would be about 12. 14 minus 2. So I think that 9 and 11, no, 9 and 11 looks to be the correct answer. Okay, but to be more precise, we'll have to actually find out the value of the POH. So I'll just find out the value of the POH. Okay, just wait. So I will do the negative log of, yeah, so we'll take a negative log of 0.08, which is 1.0, yeah, so this is equal to 1.09, which is roughly 1.1. So the pH would be roughly 14 minus that, that is about 12.9. Yeah, so it would be, sorry, it won't be between 9 and 11, it would be between 11 and 13. Okay, so let's go forward and do the other questions, right? So the graph shows the changes in pH during a series of titration. Each titration involves two solutions, each of concentration 0.1, and the question says that which graph has ethanoic acid as one of the reactants. Now here they have not said that whether ethanoic acid has been taken in the burette or it has been taken in the flask, because that could change the shape of the graph. So we have to consider from both the ways. Ethanoic acid is a weak acid, so either the starting pH should be about 3, so this is not correct, this is also not correct, uh, so this is also not correct, or the ending pH would be about 3 if it is taken in the burette. So if you look at it, you see here the ending pH is showing the presence of a weak acid, which means that this is the correct graph where you have taken the base in the flask, therefore the starting pH is 13, but because you have taken the weak acid, that is ethanoic acid, in the burette, the ending pH indicates the presence of a weak acid. So graph 4, that is D, is the correct answer. Which graph shows a solution that has an acidic pH at the end point? Now, endpoint is this part of the curve, and if you look at the middle part of this, it corresponds to an acidic pH, and therefore graph 3 is the correct answer. C is the correct answer. And which indicator is suitable for the titration shown in graph 3? So in graph 3, as you see that the vertical portion is somewhere between 4 and 6. So let's look at the indicators 4 and 6, which indicators would fall in that range. So let me see. Methyl red looks to be the correct choice. Is that the one of the options? Let me see if that's one of the options. uh, okay, so okay, which indicator is suitable for the titration? So methyl red has not been given in the options, so we'll have to go back and see if there are other options possible between 4 and 6. So bromocresol green, bromocresol green. So you can look up this and find out which would be the which would be the proper indicator which falls in the range, right? And it could be bromophenol blue or bromocresol green. Okay, so that's not a difficult question. Yeah, so bromocresol green is given as an option, so that looks to be the correct answer. Thanks a lot for watching, and if you like the video, please give it a like and subscribe to the channel. Thanks a lot.